Good evening everybody, welcome to tonight's Tutor to You session where we're looking at the exam skill of interpretation. I'm joined by Anne and we've got Jade with us as well tonight. Tonight's session we're going to have a look at this all important skill of interpretation where you may have looked back through past papers and thought, well, this doesn't actually pop up as a specific explicit command word now and again, but nonetheless it's a skill that underpins probably every type of question and every topic as well. So we're going to get started, take you through what we mean, where it might come up, what type of skill it is, and then we're going to give you some challenges throughout the session as well. So on your screen you've got your assessment objectives and hopefully you're familiar with these as returning students coming back for your second year. Interpretation is fundamentally an evaluation or an analysis skill, although it might be sometimes wrapped up in the context of contextualising questions as AO2. So we're talking about things like interpreting data, interpreting graphs, interpreting what things like the standard deviation and the mean might suggest about research, looking at distribution graphs, all things that we are going to touch on tonight. Not to mention the fact that you have to interpret your questions. We always talk in Tutor to You about decoding questions. So interpretation, even if you've got some type of calculation question, you're still interpreting the question, you're still interpreting what you have to do, what you're required to show, the skills, before you even get to doing your math. Now, throughout the session, we're going to show you examples of things that you have to do. And here's one straight up. Now, hypotheses is quite a tricky area anyway, but here on screen, we've got a little scenario about Harlow. Hopefully you're familiar with this study from attachment in paper 1. A short synopsis of Harlow's famous monkey study. And the question that we're just going to briefly talk through now is, write a directional hypothesis that a learning theorist may have written for this experiment before it was conducted. Now, I'm not going to ask you to put your answer in the chat, but I'm using this to demonstrate just how much interpretation is required for this. So we might look at this and think, oh, it's just a hypothesis question, it's just a 3-marker little research methods, but actually you've got to interpret that question, interpret that stem. Now, on this occasion, it's something you're familiar with, but lots of stems will be unique and things that you've never seen before. So time is needed to interpret them. Now, here in this question, you've got to interpret the context of the stem, the study, interpret what a learning theorist might say, before you then begin to interpret how you're actually going to piece that together to come up with a directional hypothesis. So this is why the skill of interpretation cannot be underestimated throughout your whole exam. Here's another one, sticking with Harlow. How could the researchers have collected qualitative data in this study? Same skills required. We've got to interpret the question, interpret the scenario. And actually here, I reckon a lot of people will probably put an open question. But remember, we're dealing with monkeys here. There's no questions going to be suitable in this study. So qualitative data, you've got to make sure you interpret that as the type of data that's rich and in detail. So here we're looking for something maybe like body language or the different behaviours that the monkeys show. But unless you interpret the question, interpret the stem, and interpret what you need to do and how to write it accurately, unfortunately, these questions, which may only seem friendly at first, are going to be quite a struggle. I'm going to hand you over to Anne. We're going to start introducing some tasks for you to have a go and show us your interpretation skills.
Okay, so this is the one that you're going to have a go at in a minute. So if we look at the question then, so I think if you're familiar with the study, you'll recognise that has been Van Eisen done. But if you look at the question, using Ainsworth's strange situation as a paradigm of measuring attachment types, this study wanted to investigate cultural differences in attachment. And so they used a meta-analysis. They've got 32 different studies using the strange situation in 8 different countries. They found that differences within cultures were 1.5 times bigger than differences between, and then the other findings are shown in the table. So you've got the bit of a blurb, you've got the table, and then you've got your question there. So what do these results suggest about attachment types in individualist cultures, Europe and the United States? So they've picked out, they've kind of helped you explaining which are the individualistic cultures compared to collectivist cultures. And again, they've given the examples then of Japan, Israel, and China. Okay, so we've moved to the next slide, Laura. Yeah. So to answer this question then, you've got 3 kind of things that you've got to interpret the data. So you've got the data in the table, you've got the context of the study, which you've just been given, and also what is suggested about culture and attachment type. So what sorts of things could be included in the answer? So now you can use the chat box. So what would you be wanting to say there? What do these results suggest about attachment types in individualistic cultures compared to collectivist cultures? What's that table showing us, and what does that suggest?
And would you agree, Anne, some students might know the difference between collectivist and individualist cultures, but with questions like this, they're not going to expect you to, are they?
Well, they've actually given you the examples there to help you.
Yeah. Where do you think students go wrong in this, Anne?
I think where they go wrong is perhaps by just giving you the findings and not actually thinking about what they suggest.
Yeah.
Yep. So Ben has come in there. There's more secure attachment types in individualistic cultures than collectivist. And that is true, isn't it? I mean, still the secure attachment was the most, it was the most popular one. That's not the word I want, but you know what I mean? Prominent one, yeah. Yeah. But there was a greater kind of a percentage, wasn't there, of secure attachments in individualistic cultures rather than collectivist. So that's one thing that you could say. Okay. And yet, collectivist has more resistant attachments. Yes. Okay. So, Warrior Walker. Yeah. So you've come in with another bit of information. So that's your kind of finding. So what does that suggest? What might underlie this? Why might there be these differences? How would you take this just a little bit further? Why do we have differences? What does it suggest? This is
So
the
those,
trickiest bit. And I think this is where a lot of students won't quite get to this.
yeah, those answers so far.
We've got one coming in. Yeah. Yeah, parenting styles differing between cultures. Yeah, so that's like the icing on the cake, if you like. This is how these questions discriminate, isn't it? So I think if we go on to the answer slide, I think we've got all of those things there. Yeah, Ben was coming in there as well. So yeah, and you can obviously offer some percentages to back that up as well. We weren't expecting that in the chat. So secure attachment, more frequent in individualistic cultures than collectivist, and we said, and you could back it up with a couple of percentages there. Resistant is more frequent in collectivist cultures than in individualistic cultures, which we had there, didn't we? And again, you could back that up. And then going kind of beyond that, there are cultural variances in attachment types, and they're likely impacted by cultural beliefs. And I think that's what could say. I don't know if that's how you say it properly, but that's cultural beliefs that you're talking about there. And also traditions concerning child rearing, which Warrior Walker and Ben talked about that. And as I say, that final point is crucial to show your ability to interpret what the data is suggesting and to go a little bit beyond what was actually found to kind of explain why that might have been found. Okay, so well done. So I'm going to hand back to Laura now.
Yeah, great. Thanks, Anne. So, keeping with this theme of interpretation, we often throughout your course you'll be doing hypotheses and in lots of different places. You'll be looking at your experimental group designs. So you may see them as related or unrelated when you're doing inferential tests, and you may see them more frequently as independent groups, repeated measures, matched pairs, and so on. You also will come across your levels of measurement, nominal, ordinal, and interval. And then we also have to be able to look at a STEM in a study and realise how many participants have been used, which sounds really obvious, but sometimes these things are just sneaky little bits of information in your STEM. Now, you need all of that collectively to be able to identify what inferential statistical tests you should be using. Now, you don't have to calculate these in the exam except for the sign test, but you can do that without any calculators, so that's fine. But you do have to be able to interpret a STEM and all the bits and bobs that we've just mentioned and come up with which inferential test is the most appropriate for the study. So hopefully this is familiar to you. You are going to need this, so if you don't know this off the top of your head, perhaps take a picture now. But on the left hand side, we've got the levels of measurement, nominal, ordinal, interval. Across the top, we've got our tests of. So some of these are suitable if we're looking at a test of difference. Some of them are suitable if we're looking at a test of correlation. And then also across the top, we've also got our designs, related and unrelated. So for example, if we had a study that was capturing interval data, that was looking for a test of difference and used a related design, well, if we triangulate all that on this table, we would come up with a related t-test. Now, choosing the test is one skill, but you then also have to justify it. So this is a little bit trickier. So if we go on to this, and I'm going to ask you to put your answers in the chat, we've got a STEM. An experiment was conducted to investigate the effect of word length on recall in short-term memory. In one condition, participants were asked to recall short words, and in another, the same participants were asked to recall long words. You've got everything you need in that STEM to identify which inferential test out of that table that we've just looked at would be the most appropriate. Justify your decision if you can, but first of all, let's have a look at which is the appropriate test. And you can only do that if you interpret everything that you're being given in that STEM, because none of it's by accident. It's in there because AQA are going to want you to pick up on these little hooks that's in there. So, what are your thoughts? Can we spot anything about levels of measurement? If not, we can still reach our answer. Is there anything about a design, related or unrelated, repeated measures or something else? And are we looking for a test of difference or is it a correlation? And a good way to think about that is if it's experimental, then we are going to be looking at differences. We're looking for effects, differences are something more or less higher, and so on. So, what are we thinking? Pop your answer in the chat. Don't worry if you're not spot on. This is just about practice. Some of you might be rusty with this, and some of you may not have even done it yet, but it doesn't mean we can't have a go. I can see some questions coming up about the previous topic, Anne, but we'll go back to them, okay, towards the end. All right, we've got an answer there. Related t-test, and you've given us some justification, which is great. Related t-test because it uses repeated measures and it's a test of difference. Let's see. Okay, so we've got some good justification. So we are looking for a difference. It is a repeated measures, and the data, this is the number of words, is at least ordinal. And it's
But
not,
if you did offer an explanation for why you thought that it was interval, then that would be credited, wouldn't it, in the exam, Laura?
yeah, you do get a little bit of leeway. Strictly
It's
speaking, this is at least ordinal, only because these words that they're asked to recall, there's no suggestion that these are standardised or they're all the same difficulty. But that's quite a bit mean, isn't it, really, if we just say,
Yeah,
oh,
no, they usually let it either one or
yeah,
the other,
you
because
could
even the
justify it.
psychologists can't agree, can they,
Yeah,
on whether number of words remembered is ordinal or interval.
that's right. So if you've got justification 1 and 2, but you said that it's interval, but your justification is there and it's clear and it shows that you've interpreted the level of measurement in a particular way, that's okay. So Wilcoxon, that's why sometimes you'll see it on the mark schemes that there's potentially 2 answers. That's not because it's always 2 tests that's up for choice, but it depends on your justification. What about this one then? You've got even less here to work with. A study was conducted to see if there's a correlation between the age of a child in months and the time taken to complete a maze. So thinking about what we've just done, thinking about your levels of measurement, can we spot any? Are we being told whether it's correlation and relationship or experimental and a difference? Have we got any suggestion of a design related or unrelated? Pop your answer in the chat. So Amrit asks, what's an example of a clear justification for interval? We don't mind at all. If you've got other questions, then please do pop them in the chat. For interval, like if we're looking at a really clear example of interval data, then we're looking for something that is like the most scientific measure, highly standardized. Things like time,
Equal points
temperature.
on the scale as well.
Yeah, the
Yeah,
difference
equal
between
points.
0 and 1 is the same as 1 and 2. And that's why we can't say that really about a word list. Because like I think years ago when I was starting teaching, we used to do this activity where we design word lists and people would come up with dog, apple, and then someone would put like Transylvania. And I think it was a really good example of how if a word is much bigger and harder or easier to remember than the other, then there's no standardisation at all.
It's
So
not
interval
equal, is it?
data, no, interval data, we're looking for highly scientific, standardised equal points. So time, weight, money potentially. So let's see, we've got some answers for this one. So Gemma said, would this be Pearson's? It's a correlation. Both covariables are interval, and let's have a look. And you'd be right, well done, Gemma. Megan, you've got there as well. So Pearson's test, justification, we're told it's a correlation, so we're looking for a relationship between those two specific things. And then justification 2, both covariables are interval. And there we have got examples of interval. So age is interval data, time taken to complete the maze is interval as well. So both, there's no subjectivity in them. The difference between points is objective, scientific, standardised, and so on.
And
Well
it's
done.
important on that, and the kind of saying where both covariables are interval, because if one is interval and the other is ordinal, then you have to take it as ordinal and go with the other test.
Yeah,
That sometimes trips people up, doesn't it, when they're deciding what test to use?
yeah. And you'll only come across that issue if it's a correlation, because actually you could measure one in interval, one in ordinal, if you wanted. Not necessarily this example, but then you've
Age of a
got,
child and memory would be, wouldn't it?
yeah.
That would be an example.
But for today, we're just showing that you've got to interpret all these things. And even though there's only one sentence in that stem on the screen, you've got everything you need to interpret. And if as long as you interpret them accurately and you can piece together that synoptic information you've got, you should arrive at the right test with some accurate justification. The next step to that is looking at, well, now I've done an inferential test, what does it mean? And I'm going to hand you over to Anne.
Yeah, so now we're getting to the really, really hard stuff, which is interpreting critical value tables. You will always be given these tables, with the exam question. And it will always have, it won't be the whole table, it'll be a snippet of the table like this is, because they're massive, the whole thing. And then there's always a little bit of writing under the bottom. It helps to explain how to interpret. So you have to be able to interpret what is the critical value for a study. And to do that, you kind of need to know the significance level for the study, what hypothesis has been used, how many participants there are, the calculated observed value rule for each inferential test, and that's the bit that's underneath. That's always shown. You're not expected to remember that off by heart. It's always there. And then on the basis of that, and we're going to go through how to do it in a minute, if the research is significant or not, and then if the hypothesis should be accepted or rejected. Okay, so if we look at that a little bit more slowly, so your first kind of question you need to ask yourself is what hypothesis has been used in the study. So in the blurb for the question, it will tell you that. It will either give you the actual hypothesis, or it will tell you it was a directional or a non-directional hypothesis. So when you've got a directional hypothesis, that means you're making a one-tailed test because the results can only go one way. If it's non-directional, then you're making a two-tailed test. So that's the first thing that you need to identify. And then you also need to identify what significance level is being used. Sorry, I'm just going to cough. So, and again, that's very important. I mean, we know that like the standard level, the accepted level in psychology is 0.05, but sometimes you might say 0.01. So you need to really make sure that you've identified that and you know about that, because those two things together identify which column you're going to actually start to look at. Okay, because if you can see that if it's 0.05 and it's a one-tailed test, then you're in the first column. If it's a 0.05 and it's a two-tailed test, because it's non-directional, then you're looking down the second column. Okay, so then the third thing that you need to look at is usually it's the number of participants, but sometimes that just means number of participants. The number of people in the study is 30. Sometimes it can be degrees of freedom, but for this test, for Wilcoxon, it's the number of participants. That's what N, the big N, means. Okay, so that's your third kind of thing that you need to look at. And then from that, you would deduce your critical value. So say you were making a one-tailed test, it was a 0.05 level of significance, and you had 15 participants, then the critical value would be 30. Okay, so that's what you're doing, and then sort of up on your paper, because you can jot that, you can just put a circle around it to do the next bit. Then, when you've got your critical value, you'll have your calculated value or your observed value already. That will have been given to you in the question. And then you need to compare them. You need to look at what is the rule for this particular inferential test. And that's the bit underneath. So if you look for the Wilcoxon, it says the calculated or observed value must be less than or equal to the critical value in this table for significance to be shown. So if you were on a critical value of 30, then your result would need to be less than or equal to 30 in order for it to be significant. If it was greater, then it would not be significant and you would be rejecting your hypothesis. Okay, so if we have a look at this one, so this is for you to have a go, but we'll do it slowly. So psychologists conducted an observational study to test the hypothesis males will be more likely to walk under a ladder than females. She placed a ladder over a footpath outside her office and observed how many people walked round or under it and whether they were male or female. And she analysed the data collected using a chi-square test and obtained a calculated value of 2.981. So that's what the test came out with. Then we've got the question there. So with reference to the critical values where DF equals 1, explain whether the calculated value of chi-square is significant at the 5% level. Now this is one where it isn't n, it's degrees of freedom, but they've actually told you what they are. Now let's have a little think about this one. So it said level of significance, we're using 5%, so we know that. But are we making a one-tailed test or a two-tailed test here? You need to go to that hypothesis. So use the chat just to tell me this bit so we can get on the right lines here. Are we making a one-tailed test or a two-tailed test? I'm just waiting to see if anybody else puts anything else. Yeah, you're all coming up with, most of you come up with one-tailed, and it is one-tailed, isn't it? Because that hypothesis is directional, okay? Because it's saying that males will be more likely to walk under a ladder than females. It's not just saying there's going to be a difference. Okay, so that means that we need to go along. We're using the 5% levels, that's 0.05. So we're going to that second column down. We know that DF is 1. So what is the critical value? We're going to cross to 2.71. Just came in. I was just going to give you a clue. So we know that the critical value is 2.71. Okay, so what are we going to do? Is this significant or is it not significant? You need to look at the little bit under the table there. If anybody's on a phone, this is going to be so small, isn't it? Shall I read it out? Calculated observed value has to be greater than or equal to the critical value for significance to be shown. And Megan's come in there to say that significance has been found as the calculated value of 2.981 is greater than the critical value. That's so well written, that for a one-tailed hypothesis, so we can accept the research hypothesis. Fantastic, perfect answer, Megan. Okay,
that was pretty much perfect, wasn't it?
It was. I'm just thinking back to the days when students did coursework and, and they had to like write that for themselves, and that was such a good answer there. That's fantastic. Okay, so we all kind of, so it's all right, Amrit. I mean, say it's really early days, and the more that you can practice doing these things, the better you will get at it. You really, really will. I mean, for all of research methods, it very much is practice, practice, practice. Okay, so let's have a go at the second one. I'm going to keep quiet for this one. I'm going to let you have a go yourself now. I've held your hand long enough. This time we've got n number of participants. So you need to read through the little. I'll read through the blurb, but then you can be thinking about it. So they aim to see if there is a relationship between the rating a student gave themselves for stress and the score that they obtained in a psychology test. He wasn't sure whether those who were stressed would score higher on the test or lower. So that's kind of important. After collecting the data from 10 students, he analysed it using the Spearman row and obtained a calculated value of RS equals 0.582. So, and again, that question's pretty much the same, whether it's going to be significant at the 5% level. So what do we think? Where are exam questions for research methods questions? Well, you can use past papers. Tutor to You as well. We've got a couple of booklets that have got a lot of research methods questions in.
Yeah, we've got a whole stats and maths booklet that is
Oh
pretty
yeah,
much
that one as well. Yeah, there's quite a lot.
pretty much full of these. I think AQA past papers are always going to be your best bet, aren't they? With the marks here, you've got.
But when you want some extra ones,
Yeah.
those booklets are good, aren't they?
Yeah, they are.
Okay, so where are we going? What do we think? I know it takes a little while to work this out.
But it's just still all down to interpretation, isn't it? Interpret the hypothesis, interpret all them key ingredients I went through, and
Yeah. Get to your critical value and then compare it.
Yeah, I'll put a link in. Well, actually, Amber, what I'll do is I'll put some information on our Instagram at Tutor2 Psych, and then I'll put a link in as well.
Yep, Shad Champion's coming in there. Definitely champion here. Just wait to see if anybody else is. Yep, Gemma, lovely, well-written one there again. Yep. So you're both right. Yep, you're both of you right. It is less than the critical value for a two-tailed test at 0.05. So the results are not significant, and you'd be rejecting the research hypothesis.
Okay, fab.
So
well
that
done.
is fantastic. I'm so impressed.
I'm going to hand you over to Jade.
Yeah, hi everybody. So what we're doing now is we're going to move on to the important skill of interpreting data that we might see in a graph. So this could be a scatter graph like we've got on the screen at the moment. It could be a bar chart. It could be a histogram or a line graph. So this skill involves reading the data accurately, describing patterns and trends that you can see, and linking what you can see to psychological concepts. So let's have a look at the example on the screen. Remember, every graph has a title and labelled axes, so it's always worth having a look at these first before you attempt the question. Then you're clear exactly what is being displayed in the graph. Next, read the question carefully. So let's have a look. A researcher correlated the stress scores and psychology test scores of participants. Using the scatter graph of data, explain what the data shows about the correlation. So I'm not going to get you to answer this one. We've got the answer there on the screen, but I'm just going to show you how I've interpreted the data to arrive at that answer. So to answer this question, first thing you would do is look at the plotted points. Then you would interpret them. Have I got a linear relationship that you'd expect if you had a positive or a negative correlation? So let's have a look. If there was a positive correlation, we'd expect, wouldn't we, that as the stress rating increased, the test scores would also increase. If there was a negative correlation, we'd expect that if the stress scores increased, the test scores would decrease. But we haven't got either of those things happening here. They've all scored quite highly, actually, if you have a look at them, regardless of the stress rating. So if we just pick out some examples there, if you look at there's a student there with a stress rating of 1 who's scored 12 on the test. And we've also got a student there who's got a stress rating of 7 who's also got 12 on the test. So there's no linear relationship. So what we'll do is we would conclude that we can spot that there is no correlation between stress and test scores. So that's enough. That would get us the 2 marks. There's enough detail there. We've used the data as the question demands and explained what it shows about the correlation. So that would get us the 2 marks. Okay. So let's have a go at interpreting a bar chart. So as I said previously, remember, always have a look at the title because it's got a lot of information in there, and have a look at what is displayed on both axes. So we've got a bar chart to show differences between males and females for passing practical driving tests first time or not. On the x-axis, we've got passed first time, and we've got did not pass first time, and the difference there in the bars for males and females. And on the y-axis, we've got the frequency of males and females for each. So the next thing we need to do is make sure that we read the question carefully. Again, pay particular attention to what the question wants you to interpret. So I'm going to get you to have a go at this shortly, but I'll just give you a few tips first about what you should be doing when you actually have a look at the graph. So the question says, a researcher looked at the difference between males and females in passing their driving test the first time or not. What does the graph tell you about gender differences in driving test success? So the first thing to do is look at the bars for each category. You've got passed first time there on the left, and you've got did not pass first time on the right. So interpret. Is there a difference between males and females in each of those conditions? Then what you need to do is use the data in the graph to describe what you can actually see. So in the first set, which group passed more on the first attempt, and which group had more who did not pass the first time in the second set of bars there. So in the chat box, have a go. Oh, yeah, so basically you've got blue there is males, and you've got the orangey yellow there is females. Okay, yeah, thank you, Megan. Okay, you can actually refer to the data as well in your answer, but Megan's got there that men were more likely to pass the practical driving test the first time rather than females. Lovely, thank you. Okay, so just have a look on the next slide at the answer that we've done here. Well, look, Gemma. So Gemma's noted that there is a difference in males and females. So if you just have a look at the screen here, we've put here that more males pass their driving test on the first attempt compared to females, and we've referred to the data here. So there isn't much of a difference there. You've got more males, 69, pass their driving test compared to females, 62. And we can point out here that, however, the difference is only minor. There's still a difference for you to talk about. And then for the second set of bars there, we can say more females, and you can mention the data if you want, 72, failed their first test than males, and that's 59, isn't it? So this would get the marks because you've compared both sets of bars, passed first time and did not pass first time. Sometimes students make a mistake on these questions and go wrong because they don't bring in all relevant data. So make sure if there's relevant data in the bar chart there that you actually do refer to it. And we've also made sure we've clearly used the data to state what the gender differences are in each case. Okay, thank you. So what we're going to do next is we are going to practice interpreting data in a table and on a graph for types of distribution. Now, you might not have done this yet, but don't worry if you haven't done. I'm going to give you a little tip at the end for how to recognise different types of distributions. So we're going to look at normal and skewed distributions. So lots of students find this quite tricky, but just have a go answering this. I'm going to get you to do this shortly. Remember, the first thing to do in these questions is make sure that you actually read the question carefully. So let's have a look. Here are the average scores from a study looking at performance on a memory test in a cold room, a hot room, and a room at a normal temperature. The 3 different groups of participants were shown pictures of 20 objects for 1 second at a time. They were then given a distractor task before being asked to recall as many as they could in 2 minutes. And the question says, for each group, identify the distribution of the data, and it's 3 marks. Now, to answer this question, you need to decide for each group, A, B, and C, is it a normal distribution? Have I got a positive skew, or have I got a negative skew? Now, a little tip for this question, the word identify here means that you only need to state the type of distribution. You don't actually need to give an explanation here. So identify means you can just state for A, B, and C which type of distribution you've got. So if you haven't done this or you can't remember, don't worry. Okay, just have a go. So to work this question out, what you need to do is interpret the data in the table. So if you have a look for each group, compare the mean, the median, and the mode. Okay, there is a pattern that you need to be aware of. Okay, so which is the highest and what does that show? Think about what their relationship tells you about the shape of the distribution curve. So have a go. Do you know? Okay, pop your answer in the chat. A equals B equals C equals. Okay, would it be a normal distribution? Would it be a positive skew? Or would it be a negative skew? See if you can have a go. Well done, Megan. That was very quick. Okay, excellent. So if we just move on to the next slide, we've got group A there is a positive skew. Next slide, group B is negative skew, and group C there is a, okay, so Megan's got them right, but just make sure that you do say, you've said there positive skew, you've said negative skew, well done. Do make sure that you do say for the final one that it's a normal distribution. Okay, use that terminology there, that's excellent, well done. Now, if you weren't aware of this, we just go back a slide, sorry. Okay, if you weren't aware of this, the way to recognize the difference is that with a normal distribution curve, this is your bell-shaped curve, the mean, the median, and mode are usually similar. So you've got there, they're all around 12, aren't they? So you know that the mean, median, and mode will all fall in the center of the distribution curve. The way to remember the difference between your positive skew and your negative skew is that with a positive skew, the mean is the highest, followed by the median and the mode. And for the negative skew, the mode is the highest, followed by the mean.
Can I just come in just quickly?
Yeah.
And it's very important to say positive skew and negative skew. Don't just say positive distribution, negative distribution, because you won't get the mark.
No, that was the case this year, wasn't it? There weren't allowed the marks, were they, without saying positive skew and
So
negative
that
skew.
terminology is crucial.
Yeah. Okay, as with normal distribution there. Okay, so if we just move on.
Yeah, I saw them not credit nominal distribution, which just a slip of the pen, isn't it? But
yeah, you feel dead mean, but that was the rule.
But they were very, very stringent, weren't they, this year with the terminology of those? So.
yeah.
All right, let's have a look at another one then. This time we've got them displayed on a normal distribution, on a distribution curve here. So again, remember to read the question carefully. So we've got a study looked at the effect of temperature on memory, suggest what this graph tells us about the distribution of data. So again, this is worth 1 mark, but unlike the last example, this isn't just about naming the type of distribution in this one. Here, you need to actually use the data and explain what it shows. So before you answer this one, I'm going to get you to answer this one in a second, but before you do, just remember to actually look at the curve, look at the data, compare the positions of the mean, the median, and the mode, and then interpret which one's the highest and think, what do I know? Okay, what do I know about the positions of the mean, the median, and the mode? And then explain briefly what it means. Is the data showing a normal distribution, a positive skew, or a negative skew? So have a go again. Okay, drop your answers in the chat. What do you think the graph is showing? Okay, so can we elaborate a little bit further? Well done. So you've both said there, Chad Champion and Ben, the graph is showing a negative skew. We just need to take it a little bit further to get the mark. How do we know? Use the data. So could you both elaborate there? How do we know we've got a negative skew? Refer to the positions of the mode, the mean, and the median. Well done, Ben. Yeah, the mean is lower than the median and the mode. You can do it either way around, can't you? So you could have said the mode is higher than the median and the mean. Well done. It doesn't matter which way around you say it. Lovely. Well done, Chad Champion. So if you have a look at our answer on the screen here, we've put the data is negatively skewed because the mode is higher than the mean. That's enough to get the mark because you've not only identified the type of distribution, okay, you've actually used the data to explain why it's a negative skew. Okay, thank you.
Fabulous. Thanks very much, Jade. So as you can see there, we've touched on various topics tonight, but interpretation actually underpins all of them, doesn't it? So a very much needed exam skill. We've got lots of practice at this again over our next few sessions. So we're going to be looking at calculating things, justifying things, evaluation, all these important skills that slowly start to snowball into each other. The goal is to be able to do it all at once in any question that pops up. But for tonight, thank you to Anne, thank you to Jade. You'll be able to watch this back on demand on YouTube. You got loads of great tips off Jade and Anne tonight, especially with those critical value tables. Go back through it, watch it again, pause it, use it for practice. And hopefully you'll improve in your confidence as well as your interpretation skills. You can also check us out for some more tips on Instagram at Tutor2Psych. If you didn't get any of your questions answered tonight, then head over there and contact us. We'll get right back to you. But thank you, Anne, Jade, and we'll be back next week at 6 o'clock. So we will see you then. Good night, everybody.
Bye.